Hello Internet! In this video we are going to be making the Mass Effect Andromeda self-building bridge. I'm totally blanking on what it's called. They have a name for it in the game. It's like a self-building 3D printed bridge. And so the idea here is it's a bridge that builds itself as you walk across it. So as you're walking across the bridge, right in front of you it's laying down new pieces for the bridge. And I've seen this in a number of games, but Mass Effect Andromeda just came out, and I've been playing it, and I don't know, the effect is just really cool, and I like the way they do it, and it looks really interesting. So I've been thinking about how to implement it. I've come up with a number of ideas. We're gonna do one of them, and I'll talk a little bit about some of the other ideas I've had. So what we're going to do is we are going to use 2 points to make a line that's going to form our bridge, and then between that line we're going to track how far across you've traveled. So the idea is pretty much, they're going to start from one side or the other. So you'll have a primary point and a secondary point. We could do some additional work to make it work from either direction, but I don't think that's needed. So I'll kind of lay out what I'm thinking. We're going to have our bridge, which I'll just put right in the center there. And then we're going to have a start point and an end point. So these are I'm using objects just because they're easier to move around, and that way everything just kind of works a little bit better. So we can kind of rotate it and do all sorts of other things. So I'm going to make it, say, 10 wide. So each of these will be at 5 and 5, like so. And so effectively between these two points is a line. And the idea is we can actually use the dot product between these 2 points and then our player, and then calculate. So if this is, say, positive, we know it's going across the bridge. So if the vector between point 1 and point 2 and point 1 and our player is positive, then we know that they're in between here. So we can actually do that both ways to figure out if they're inside of this line, and that way we know they're inside the bridge, at least along that axis. And then we can do a little distance calculation from that line to calculate that, and that should be enough to kind of lay down the foundation. So this is going to build sort of horizontally, so it's going to do an entire length wide. The other thing I was thinking of is we could do like a binary or like a Boolean array, and it'd be a similar idea, but it'd be a little bit more advanced. So you'd have sort of a 2D array of Booleans, and you'd kind of march them across one way or the other. And since they'd all be equally sized, you'd be able to calculate their position, their size, and all of that, just based off of the index and then where they are in the array. But I'm not convinced that that's worth the work, because I think this will work pretty well. So we're just going to get started here. The first thing I'm going to do is just do a bridge builder. I'm always so bad at naming these. So we're just going to start off, and we're going to just draw the line between the two. That should be really easy. And so I think what we're going to want is 3 points. We're going to want a public transform for our point 1, and a transform to point 2. We're going to call it our endpoint. Ooh, that's not it. Endpoint. And our start point. That way things make a little bit more sense. So we've got those. Let's do on draw gizmos, and this way we can just kind of draw where those points are. So I'm going to enable them and just draw the start a nice green circle, because why not? So we'll draw a wire sphere. And this is all more for debugging, just so we can kind of visualize what's going on. It's not actually, none of this is actually really going to help our actual implementation. It's more just so that we can see what's actually happening. So I'm going to make these 0.5 meter wide, so give them a radius of 0.25. And then do the same for the endpoint, but we'll make the endpoint red. And then just for completeness sake, we're going to do a white line between the two. So we're going to draw a line from our start point position to our end point position. Ooh. What am I doing? There we go. So that's pretty much all we need to do there. And now they should pop up there. We can drop our start point in and our end point. And now we get this really awful looking thing. So it doesn't look good. It wasn't really designed to look good. But the idea here is now we can actually see where things are. So the start point, the idea here is if we take the difference between 0.2, 0.1, we'll get a vector going down this line, going that way. Yeah, that way. Sorry, I'm trying looking at my camera and it's hard to figure out which way it goes. But anyway, it's going down the line from green to red, and then as our player walks across it, or as whatever object we want to go across it, I'm probably going to have a tracked object on there as well. But as it goes across it, we're going to track how far across they've actually gotten. And then based on that, we can hopefully figure this out. I'm thinking there may be this may get more complicated than I wanted. So like I said, I was playing the game, was like, we should make this. So we're making it. But I have no idea how this is going to go. So I'm going to add a player. We're not going to use the camera just because I don't want to. No real reason, just mostly I don't know. No, there's literally no reason. We're going to stick a transform, and this is just going to be our tracked object. So one of the things you're going to notice is I'm not actually going to put any physics into this. There's not going to be any physics collision because since the idea is this is going to build underneath you and you're never going to be able to outrun it. The idea here is that the physics can just be static. The physics can just stay there, and then as you kind of run across it, the actual graphics appear, but the physics was already there. So you don't need to do that much extra work, because adding physics for like all of these special things, you could do it, but it'd be really expensive and it's not worth it. So we're not going to do it. So I'm going to track my player. And now we need to do something. Let's create a quick prefab. So this is literally just going to be a cube. Like I said, we don't need physics, but we need a cube. So that's what I'm making. We have our cube. That's it. Then what we want is, with our bridge builder, we can take that and assign that prefab. So bridge prefab. And then we're also going to create a size for this. I'm going to give it a length equal to 1. and that will be the length along the bridge. And so that you have to travel that far in increments. And then we'll also do a width of 1, and then an int array, or an int size, and that'll be column width. And for now, I'm just going to leave that as 1. We're just going to do a single line down it. But the idea here is you can actually spread this out, and it will hopefully work just as well for any of this. Not too sure about that. It should be fine, but I don't know. We'll see. So we've got all of this stuff. We have that. I'm going to grab our cube. And so the idea here is we want to effectively march down. We want to march down our points. So we're going to assume, we're going to assume that our points aren't going to move. So this is mostly in optimization. So now that I say that, let's not do that. Again, we'll ignore optimizations because that's going to depend on your use case. So you optimize for you, and we'll build it the easy way. Or actually, this is probably going to be harder. But anyway, what we want is we want the forward vector. So this is going to be taking our start point. How do we get to the end point? And so the way we do that is we take our endpoint dot position and subtract off our start point position. Oh, there we go. So this gets us the full difference between the two. That's not what we want. We want this to be the normalized length. So this will give us a unit vector along that line. And then, that should be good. So let's start. We could do this with a for loop, sure. I don't think I've ever done a for loop with a vector before. Let's try it. So we're going to create a start point, or we're going to create a point. So all I'm trying to do here is just initialize cubes down our line. And then what we can do is take that and kind of abstract that out, and not really abstract it out, more just slow it down so those points don't exist all the time. We just create them as we need them. So we have our point. This is going to be our start point dot position. And then we're going to continue this loop until our dot product. Yeah, this is going to get weird. So until our dot product of our forward vector and our endpoint minus our current point, we need to do the position of our endpoint. There we go. Is less than or greater than 1. Greater than 0, sorry. So, how this is working, before I get to that, let's finish this off by just incrementing our point by the forward vector times our length, so how long our vector is. So let's talk about how this works. So we're starting at our start. That's easy. And then what we're going to do is every loop we're going to move the point down our line by the forward vector. So down the line by our length, which is representing the size of each of the steps of it. So the hard part, not really the hard part, but the confusing part is the ending bit. So what we're doing is we're doing a dot product between our forward vector. So we're saying one is we're pointing something down our line, but then we're also finding the difference between our endpoint and our point, or our endpoint position and our point. So initially our point and our endpoint minus our point is going to be exactly the same as our forward vector. They're going to be exactly the same. But as soon as we pass our endpoint, once that happens, that dot product is going to flip, because suddenly this point is actually going to be further down the line than our end. And when that happens, the dot product becomes negative because they're in opposite directions. So that's how we're detecting when to stop, I think. We'll see if it works pretty quickly. So what we want to do here is just instantiate a bunch of things. Not a bunch of things, just a few of these. So we're going to create a bridge prefab at our point with, let's do actually quaternion.look, and we're going to look down our forward vector. So this is just creating a really quick look rotation, so we're just pointing all of the objects down our line. This way, if we kind of skew our line, everything kind of still works. So, assuming I did this right, we should get a number of cubes. So the one thing you'll notice here, it doesn't go all the way to the end, because at that point it should, I believe, be 0. And we can test that pretty easily by testing for equality. Let's see. Yeah. So now we've accounted for that final point, and we built 10 cubes going down our row. So now what we need to do is, instead of doing these now, we need to create them as our player comes across them. Which means we also are going to need to track this current point. So effectively what we're going to do is we're going to move this point down our line, but we're not going to do it in a for loop. Instead, what we're going to do is we're going to do it based on the player's position. So I don't know how to do this the best way. I didn't really get this far in my considerations, so we're going to make something up. Why not? The first thing that's occurring to me, let's cache our point, our last point. So we can start this, and I'll just initialize this here. So our last point is actually going to be equal to our start point dot position. And so there's an end series for this, which is going to actually be this guy right here. So when this happens, when our pen. Right. So when this happens, when our dot product is greater, we can actually just remove this script. We've created all of the objects we're going to create. The bridge doesn't need to go away. We can just destroy this. So by calling destroy this, we're not destroying the game object. We're just destroying what's attached to it. Specifically, we're destroying the script. We're not destroying any of the other things attached to it. We won't remove the physics, for example. That should all stay there. We just are getting rid of that. So let's plug in our last point there. And then also we're going to want a forward vector. So this is what I was going to do before. We're going to need this, and with this sort of implementation, it's not really going to work if you start like dynamically like moving your bridge around after you started creating it. It doesn't really make sense. I don't know why you'd want to do that, but if you do, this won't work. You'll need something else. So yeah, there's that. For our forward vector, let's just do that. Boom, done. Should work. We can drop that. And everything is still going to work. So now the next bit is we actually need to track where our player is in relationship to this whole thing, which I'm not entirely familiar with how to do. We should be able to, we can figure out where along a line somebody is, which is what we need to do. But I'm not sure the best way to do that. So we're going to have, I'm just winging this here, but we're going to have a point, or we're going to have an endpoint, which we can use, going towards our last point. And so we can take that vector, that's going to point towards our player. And then we can also take that last point and... no, that won't work. Good point. Good question. I'm going to go write this down. That's a good idea. So I'm going to be back there and draw something. I don't know what it's going to do. I don't know what it's going to look like, but I will be right back. And we'll see what I come up with. I don't know. Okay. So here's sort of what I've been thinking of. We're going to take two dot products. We're going to take our end to player, not player, our end to point. So first off, we're going to need a special point, which is going to be equal to our last point minus our forward vector. So we're going to be 1 point back from it, which will be like the tile before the one that you wanted to create. So we can actually use some sort of scalar probably to adjust this so that you can actually have it, if you want the bridge to spawn way out in front of you, you can make it a bigger number, and if you make it really small, it will spawn like right in front of you. This is going to be exactly one meter in front of you, which for now, just to make sure this is actually working, that should be fine. We can add that scalar on later. That's a line of code. So we're taking two dot products. The first one is from the endpoint to our new point. So that's going to go from our endpoint position to our point, which this isn't how you do this. Sorry, we're getting two vectors, and then we're calculating the dot product of them. So that wasn't what I wanted to do. There. Okay, so if we subtract these two, this is going to be going down towards that. I actually want this to point backwards towards the player, just because that's the way I drew it. It doesn't really matter one way or the other. They just have to be the same. And so what we're doing is we're taking that point, that vector, and seeing we want to spawn a new point when this position, or when this becomes in line with the difference between our point and our player. So if we plug in player to point, which is going to be equal to our point minus our tracked object dot position. So same thing. What's going to happen is as soon as our player moves in front of that final object, we're going to spawn something. So effectively, that's why we're moving it back, because if we did this normally, you would already be over empty space. By moving it back, we're taking you back a little bit, and then it should spawn in front of you. So if our dot product of those two, end2point and player2point, is greater than 0, so if they're in alignment, it doesn't necessarily have to be 1, and it could actually be, we're not normalizing these or anything, so it could be a pretty big number depending on the size of your bridge. But all we need is it to be positive. So there's some kinks here. One of them is going to be, this doesn't really work in 3D, not yet. You'd have to do a test to see if it was in the width of it. I don't think we're going to get to that just because that may be another video or something, but for now, we're going to stick to this. But all we're doing is testing when those two fall in line, when they become parallel to one another, not parallel to one another, when they're going the same direction, then we want to spawn our new point, which is going to mean our point is going to increase. So our last point is going to increase by 1, which means we increase it by our forward vector times our length. And that happens after we've instantiated at our, not our point, but at our last point. So as you move across, it should spawn cubes. And so obviously in Mass Effect, for example, there's animations or something. Well, that didn't work. Oh, duh. We still have this. That's not gonna work. There we go. So we get rid of all those. Those weren't needed. We should start with nothing, and we do. And so I should be able to move this forward. And something should have happened, but nothing did. Interesting. It also doesn't, what? Hold on. Why is that disappearing? Okay, I'm going to take that out. We're going to pretend like that doesn't exist anymore because it was deleting our script, which it shouldn't have. But yeah, cool. So it is working. So there's our player. And as they move down, you can see it spawns. And it doesn't go beyond. It didn't remove the bridge. The script is still there. But I don't think that's that big of a problem. So like I was saying, in Mass Effect, these would have like an animation, which is actually, that's super easy to do. If we want to do something like super simple, like ridiculously simple, we'll just have like a fade in. So normally I do this with like a mechanism animation or something just so that we could tweak it and keep it up to date. But there's not, for this, it's going to be super quick. So we're going to add a quick speed, and then once this is done, then I think this is working. There's a few tweaks to make this work in 3D because the way we have it, even if you're way off, like way off to the side of it, it's still going to spawn because it's only checking when you're directionally across from it. It doesn't look along that width. But we can fix that. And we probably will in the near future. But I'm going to give it a depth, I guess. We'll set this to like -100 and the speed equal to 2. Sure. And then the start, we'll set the transform position equal to, let's create a timer. And so we're going to just set this equal to a new vector3 equal to its position dot x, and then its position dot y, or dot z, sorry. So its x and z aren't going to change. The only thing we're doing is fading it in from the bottom. So the way we do this is do timer minus, or 1 minus the timer. So our timer is going to go from 0 to 1, and then it's going to multiply by the depth. So what this is going to do, our depth is -100. As our timer increases, this is going to get closer and closer to 0, because our timer is going to count up, which means we're subtracting more and more from this until eventually we subtract 1 from 1, which just gives us 0 times whatever, it doesn't matter, we get 0. So that's going to just fade up. And so if we want, actually, to give it sort of like an exponential curve, we can give it a power of like 2. That'll just give it a straight exponential curve. And then, what else? That sets our position. We'll just copy it down there. And then all we need to do is increment our timer. And actually we can just set it equal to math clamp 0, 1, which is going to clamp it between 0 and 1. And then all we're doing is doing timer plus the time delta time times 2. Not times 2, times the speed. So the speed, this way we can just make it faster than 1 second. Otherwise it'd be hard-coded to be 1 second. The speed lets us kind of add a factor to that. So if we give it a speed of 2, it'll take half a second. Speed of 4, it'll take a quarter, so forth. Yeah, nothing crazy going on here. Just really quick animation to kind of add some visual flair, I guess. Why not? So all I did was assign the script. We had the defaults already set, so I shouldn't need to do anything. And now I should be able to move this along. So obviously that was behind, but you can obviously tweak that to get it however you want. But you get the idea. As you move across, I can move this way down here, just so we get even more. But as we move our player down, you can see it slowly starts building the bridge. And even if we move really quick, it still works. And yeah, everything's doing well. So yeah, there's our bridge. If we want to make this happen so you don't like run off the edge, like this is really close to the edge, obviously. So it's probably good for like a walking speed, but not great if you're like driving a car, for example. So that scale we talked about earlier, to make it push back a little bit further so that you move where you're checking from a little bit back. That would kind of help tweak how that whole thing worked. You could even base it off of the actual player's speed and make it intelligent enough so that no matter what was moving across it, it would always build fast enough. But we're not going to talk about that here. So yeah, I don't know. I thought it was an interesting thing. It's actually super simple. We did this in 30 minutes, and I don't know, I think it's cool. So yeah. that's it for now. So if there's anything you guys want to see, let me know in the comments. If there's anything you want me to change or improve or do differently, let me know as well. That's how I figure out what to do and how to do it. So yeah, it really helps me out. So yeah, that's it. So until next time, see you, internet.